Hello viewers, I am Sejal Chopra and this video is an introduction to interrupts. Have you ever wondered why interrupts are important in microprocessor based system? Consider a patient health monitoring system or an industrial application like measuring and controlling the temperature of a furnace or pressure of a boiler. All these would require interrupts for their working. I would be dealing with one of these examples to explain interrupts. So, by the end of the video, you should be able to define interrupt, explain why and how an interrupt occurs, and explain different data transferring schemes. What is the literal meaning of an interrupt then? It means a break, some disturbance, discontinuity, or halt. In microprocessors world, it is a signal which breaks the normal sequence of execution of instructions, that is, it suspends its normal working. So now, there arises some questions like, what is the normal working of a processor? If there is normal working, then why an interrupt occurs? How does normal working get interrupted? And then, what should be done next? Let's answer these questions using an example of patient health monitoring system. Using this system, we are monitoring the temperature and heartbeat of a patient, and these are displayed on a device. What does a microprocessor do here? Processor is going to run a program which is stored in the memory. This program will continuously take inputs from both the sensors using I/O interfacing device and display them on display devices. It is going to continuously compare these inputs with the standard values. This is the normal working. Then, why is the processor required to be interrupted? Processor is going to be interrupted whenever sensor inputs are going to exceed the normal ranges. How will it interrupt? It can be interrupted on any of the pin of the processor, that is using a hardware interrupt pin, or it can be done by writing specific instructions in the program, that is using a software interrupt. In our example, we had a software interrupt generated when using a compare instruction which found a condition where sensor inputs exceeded the normal range. So, what should the processor do when it encounters interrupt? Remember, in every interrupt, we have two parameters which are associated with it. One is the name or number, example INTR or N21H, and the other is the main memory location where the other program known as interrupt service routine is to be executed. In our example, normal program is monitoring and displaying the sensor values. Whenever these values exceeded the normal range, the processor stopped its normal program execution and immediately executed a program which would either activate the buzzer or send information to the mobile using Bluetooth. When hardware devices on computer produce events, we need some mechanisms to handle these events, wherein the operating system would deliver them to applications. Hardware devices may generate these events which are not having specific patterns, or maybe they occur at random times. For example, we may not know when the user would press a key until he actually presses it. Similarly, if we have an incoming network packets in a workstation, and we have messages coming from a network, we don't know the order and the timing of the messages. Same would be the case with random mouse movements. So, how is this information generated by these events transmitted to running applications? We can understand this through an analogy of a classroom where teacher is going to be a microprocessor, students are I/O devices, the normal program working is the lecture delivery, Interrupt may be any doubts that are to be resolved, and ISR may be the response of the teacher to solve students' doubts. There are two ways in which doubts can be handled. The first method is where the teacher explains some part of the lecture content and asks each student one by one whether he or she has any doubts. After resolving their doubts, if any, the teacher would come back and start with its normal lecture delivery. The second method would be where teacher continues with lecture delivery until some student interrupts for a doubt to be solved. Which one do you think now is going to be a better way of handling doubts, and why? Remember, in the first case, the teacher goes out to each student asking for doubts even if he won't have. This happens at regular intervals. Moreover, any student who would have a doubt would have to wait until his turn comes. This will cause a delay in solving his doubt, and at the same time would waste teachers' time also in asking those students who didn't have a doubt. This problem can be resolved in the second case, where one who really wants to ask some doubt would interrupt the teacher. Same is the case of microprocessors, where there may be two options of handling events of hardware devices. The first option is where MUPI goes to each device at regular intervals asking whether it wants to communicate while stopping its own normal program execution. This is known as polling or programmed I/O method. The second option is where the I/O device who wants to communicate with the MUPI, he may send a request. This method is known as interrupt-driven method or vectored method. A special mention here, students, you can have a Viva question on comparison of these two techniques. Let us take both these methods one by one. First method. Polling method is also called as programmed I/O method, as MUPI periodically checks devices under the software control. In this system, MUPI has only one interrupt line for communication. This system would be appropriate only in cases where there are limited number of I/O devices to be interfaced. But since this method had major drawbacks like MUPI wasting its time in asking all devices, devices having no priority in getting serviced, and delay in responses to a requesting device, the better option obviously for communicating devices was to use an interrupt-driven method. Interrupt-driven method is also known as vectored method. In this method, the requesting device interrupts the processor whenever it wants to communicate, and since the processor knows the memory location from where it has to run the ISR program, it is also known as vectored method. Here, each device is connected individually. It can have prioritized service without any delays in the response. But remember, the processor, whenever interrupted, would be stopping the main program to service the device, and the transfer rate would be limited by the speed of the CPU testing and servicing the device. Thanks a lot for watching this video.